Okay guys, question 12. We're modelling a rope or a suspension bridge, with this diagram up here that we're given in the question, and we're asked to find an equation to model the sort of the rope suspension part here. Okay, so we've got some coordinates. We know the 0, 0 is here, the origin is here, and we're 100 meters. The towers are 100 meters either side, so they're going to be at minus 50. 24, that's point P, and then the point R, the top of this tower, is at 50. 24, the towers are 24 meters high. Q is 4 meters above the ground, and it's above the origin, so it would be 0 and 4. And I need to model this. It looks like we've got the shape of a quadratic, so I'm going to set out the general form of a quadratic. So y equals ax squared plus bx plus c, and I'm going to put in this coordinate here. So x is 0, y is 4. So 4 equals a times 0 squared, 0, plus b times, that shouldn't be squared, should it? B times 0 is 0, plus c. So we just have 4 is equal to c by substituting in the first coordinate 0, 4. Okay, so that was easy to get that out. The second part, working out A and B, probably going to have to do that together using simultaneous equations. So I'm substituting in the two coordinates that I have left at the top of the towers, P and R, into this equation here. All right, so they both equal 24. So I've got 24 for both of them. That's the y value. And then we're just looking at, right, we've got ax squared, which is going to be a times 50 squared for the minus 50 squared, which is 2,500 for the first one, plus b lots of 50, or minus 50 for that one, plus c, which is 4. Second one is a times 50 squared, which is the same as minus 50 squared, and then we've got plus b times 50 this time, not minus 50, plus 4. Alright, tidying both of these up, well, I could just go ahead and subtract it here, but if I try and tidy them up a little bit here, I'm going to take away the 4 from both sides. So I'm going to end up with 20 is equal to 2,500A minus 50B, and also 20 equals 2,500A plus 50B. Alright, and when you do simultaneous equations, how do you get rid of the a's? Because they're the ones we have the same amount of. If we subtract these equations, then we'll end up with nothing, 0 equals 0, minus 100b. Okay, so if you want to know what b is, then you've got 0 over minus 100 equals b. B is 0. So that's our b value. B is 0. And now there's loads of ways that you can get a. You can just substitute b back in and work it out. So I'll take one of these equations up here, and I'll do that. I think I'm going to do 24 equals 2,500 a plus b is 0, effectively, plus 4. Alright, b is 0, so that cancels that term out. I'm using this equation here to work out a. So again, I'm going to get 20 equals 2,500 a, 20 over 2,500 equals a. Stick that into a calculator, and what do I get? 1 over 125 equals a. So that's the a value. Alright, so that's how you get the equation of this curve. So if I try and squeeze it in down here, we have the equation for this is y equals 1 over 125 x squared. That's the value of a plus 4. That's going to be the equation of our quadratic that models that bridge. It says, second part B, Lee can safely inspect the cable of a height of 12 metres above the walkway. A defect is reported on the cable at the location of 19 metres horizontally from one of the towers. From one of the towers, 19 metres this way. Okay? Or 19 metres this way. So, can he safely inspect the thing? So, what is the x value here? We've got a formula here to work out the height. You know, the height is y, so y equals 125. Put in your x value, square it, and add 4. I should have got 4 in there, really, shouldn't I? Don't know why I didn't do that. C is 4. So, we've got to work out your x value. So, what is 50? Take away 19. Well, it's going to be 31. And that does equal 11 point, I did this on a calculator earlier just to check it. Let's talk amongst yourselves while I flick through my notes. What did I get? 11.688, which is obviously going to be less than 12. So yes, he can safely inspect at that point, alright? And just to save me adding on an extra bit to this video, last part's only for 1 mark. Give a reason why the model may not be suitable to determine whether Lee can safely inspect. This is very close. So any slight variation in this model is going to be a cause for concern here. So that in a real life model, we're talking about a suspension bridge. Suspension bridges are open to the weather. In particular, wind could move that rope out of place. So we've got wind. This bridge here is, again, this is a model, isn't it? And it's assumed to be horizontal. So that bit there may not be exactly horizontal. I'm not writing too much here because my pen doesn't allow me to write very neatly because I haven't got used to it yet. So you can see struggling to write anything really that you can read. But remember those reasons. Anything that would affect the shape of this in the real life situation could be a factor to why this would not be very completely safe. It's a concern, isn't it? All right, it's so close. Any slight variation due to anything in real life could cause that to be not true. We don't want Lee to get injured.